Hello, everyone, and welcome to Lecture 7 in our course on drugs and behavior. So this lecture is the beginning of the fourth week of our class, and we'll start talking about drug use and its impact on society and the individual. So far we've talked about uh, the history of drugs, going back to ancient history and moving up to almost current times. We talked a lot about the brain, and that sort of lays our foundation for how drugs have their effects. Why are drugs specific to a particular set of behaviors, for example? And so now we're going to build off of that foundation and start talking about society at large, and in particular U.S. society. And from there, we'll move on to things like drug policy, drug regulation, and in a couple of weeks, we'll get into individual drugs and really get into detail on drugs one by one, or classes of drugs one at a time. So for this week, what we're going to do is look at drugs and their effect on society. And of course, society is comprised of individuals. And so we'll begin by looking at the individual. Now, the last couple of weeks, we looked at the brain of the individual. So really looking at even small scale phenomena like how drugs have their effects on individual neurons, individual brain cells. And so we're going to look a little bit larger scale than that now, look at the individual and individual behavior and physiology. And from there, what we'll do is look at how society classifies drug use. So dependence, for example, will be a big topic this week. How do we determine whether an individual is dependent or not on a drug? And how do we understand drug dependence? And there have been a variety of ways to look at that problem. And then, how do drug users affect society? And that's, of course, that's a two-way street. Society, through things like policy, regulation, attitudes, affects individual drug users, but drug users, as we'll see, can also have an effect on society. So in this session in particular, what we're going to do is first learn about individual effects of drugs, again, at a larger scale than we've been looking, larger than the brain, so looking at the whole body. So learning about drug toxicity. And then we'll look at where we get some of our information in terms of drug use. So there are a couple of organizations we'll focus on that determine what drugs are involved in a person's actions or a person's death even, and how do we use that information? What are the strong points of that information? What are the weak points? What are the kinds of information those organizations don't provide to us? What we'll also do is learn about larger social consequences of drug use. And we'll start that in this session. Next week, or next session, we'll actually start talking about that a little bit more in terms of things like crime. Uh, this session, we'll talk about one particular aspect of drug use and its consequences, and we'll move on to the bigger picture next time. So before we get on to this session's content, I will, as always, go over some of the discussion questions from last week. As always, I was very impressed with everyone's responses. Everyone had very thoughtful responses. Um, there were a few of you that didn't participate in the discussion this last week, so again, it's part of the course. If for no other reason, it's part of your grade, so please participate. Uh, but it's been really interesting seeing the discussion, responding to it. So be sure to keep that up. But everyone that responded has done a great job. Some very insightful comments, and some good back and forth too. So one of the questions was about the placebo effect and the importance of double-blind procedures. So one thing that was commented on a great deal was the positives of the placebo effect. If you can give someone an inert sugar pill and they report things like less depression or less pain, then that's great. You don't have to give them a substance that has negative side effects, and they still report an effect. Of course, that depends on their not knowing that it's a placebo. As soon as you tell them it's a sugar pill, that effect really goes away. Um, so there is sort of an ethical issue there if you want to propose giving a placebo to people and claiming that it is, or at least could be, an active drug. So there's an element of deception there, and uh, ethical boards for things like chemical companies, academic institutions, uh, they they frown on deceptive practices. Uh, so there are some positives, but again, you have to, in at least a partial sense, lie to the drug user, the person taking the placebo, for it to be effective. Of course, the main point of the double-blind procedure is to eliminate bias, both on the part of the participant in the study and the researcher. So we just talked about, if the person thinks that they're getting a drug, they will often report alleviation of symptoms, uh, but the researchers involved also. And in both cases, uh, we have to realize that, of course, a lot of these biases may be unconscious, right? The participant in the discussion may expect, in an experiment, may expect uh, to find relief from pain, and so they report it. It's not an intentional effort to be deceptive. Likewise, a researcher that's administering the study may not intend to pay more attention to pain relief in the legitimate drug group versus the placebo group. It may be unconscious, not necessarily, but it can be. It often is. And so we have to make a distinction between intentional deception by the participant or the researcher and unconscious bias. So that's one issue. Uh, Another issue, again, is a ethical issue that was brought up, and that is, uh, what if someone's in the placebo group? They have an actual disease, right? There's something that they're seeking relief from. How ethical is it to put them in the placebo group? And again, they may experience some relief, but for a drug that works, not as much relief as if they were in the drug group. And there are provisos often in clinical studies, especially uh, for drugs that treat life-threatening conditions, that if it becomes clear that the drug is effective, then the placebo group stops being the placebo group and they get the drug. So there's that as well. That's another ethical issue. And of course, in terms of bias on the part of the researchers, uh, they, of course, want to develop a substance that helps people, and that may bias their interpretation. There's also a financial component, so it's a little less beneficent if they interpret the results in a way that make the drug look more effective than it actually is. But there's lots of sources of this bias. They want the drug to work because they want to help people that have a condition. They have a financial incentive. They may even have pressure from the administration of the company they're working for. So again, that can even be an unconscious bias. Authority figures, especially when our livelihood depends on appeasing them, can have a huge effect on our behavior. People often engage in unethical behavior, but when that authority figure is telling them to do so, they often sort of lose that ethical check on their actions. This has been demonstrated over and over again, not just in terms of drug trials, but in many domains. Okay, so a second question was about drugs and synaptic transmission, uh, and that is why why do drugs usually act at the synaptic level as opposed to affecting things like action potential transmission? So we talked about both of these phenomena, how a neuron transmits information from the dendrites to the axon terminals via an action potential, and that depends on electrical currents, depends on ion channels, and of course at the synapse there are also things like ion channels that allow information to be transmitted from one neuron to the next. One of the things that was commonly remarked on was the complexity of synapses, and that's true. Synapses have a lot more targets, so to speak, for drugs. There's a lot more chemical machinery. Receptors on the postsynaptic side have more places that a drug can latch onto. There are lots of different neurotransmitters, and a drug can imitate one of those. There are multiple steps in synaptic transmission, and a drug can interfere or enhance any of those steps. So there's a lot more places for a drug to alter synaptic function than there are places for a drug to alter action potential function. One of the other big issues, though, is that synapses are diverse. and primarily in terms of the neurotransmitter they use. Action potentials are pretty much the same no matter what kind of neuron you're talking about. So if you have a drug that acts like dopamine does, then that's really only going to affect those dopamine synapses, which are a very small subset of all the synapses in the brain. Or a drug that only affects a certain kind of receptor. And of all the receptors in the brain and all the neurons, that's only one kind. So you can be fairly specific um, with that kind of drug. Whereas again, action potentials are more or less the same throughout the brain. And so if you change something about action potentials, uh, that's going to have a pretty global effect. And most of the drugs we want to administer, most of the symptoms we want to alleviate, aren't that general. So we want to enhance movement, for example, without affecting mood. Or we want to affect pain perception without affecting sensory perception in other domains. And we want to do all this without really affecting autonomic function. We don't want to slow someone's heart rate down just so that they can feel less pain, although that is one of the side effects of things like opioids. So we want to minimize side effects while really specifically targeting a particular symptom. And that's hard to do with something that just works on action potentials. Now, there are certainly chemicals that alter action potentials, but most of these are toxins, they're poisons. So things like pufferfish toxin, which is very dangerous. If you've ever heard of a fish called fugu in a Japanese restaurant, a sushi restaurant, that's a very poisonous fish, but so you have to be very careful about which part of the fish you eat. But that is a toxin, that fish contains a toxin that really interferes with action potential transmission. And there are lots of these different kinds of toxins, but usually something that affects the nervous system globally like that by affecting action potentials isn't going to be specific enough to be a beneficial drug. Okay, then finally, the third discussion question was about the basal ganglia. And the basal ganglia are a set of brain systems, a set of regions in the brain that do two things. They seem to be involved in processing rewards, and they also seem to be involved in initiating movements. So there's a reward processing component and a motor control component. So the question was, why would you have this one system of the brain do both things? And one of the common answers, and a good one, was that there's a connection between actions and rewards, between behavior and what we find rewarding or, in a larger sense, pleasurable. And that is, we tend to make actions, to commit actions um, that are rewarding. We avoid things like pain. We avoid things that deprive us of resources. And we like to seek out things like food, like sex, things that are generally pleasant. And of course, what's pleasant and not behaviorally is something we've evolved to perceive. Um, so organisms that don't perceive food, sex, water as being rewarding tend not to propagate their genes in the next generation, especially if they avoid these things. You don't last very long if you don't seek out food. So there's this connection between actions that are direct, especially those that are directed toward a goal, and the rewards that achieving those goals produce. So it makes sense for these systems to be closely tied together, and in this case, they're even processed, at least partially, by the same set of regions in the brain. Another idea that was brought forth was the importance of dopamine. And dopamine is a very important neurotransmitter. It's not the only important one, as we'll see when we get into individual drugs, but a lot of the drugs of abuse in particular, that is, those that are more likely to make a person dependent on them, seem to involve the dopamine system. But dopamine is also involved in processing rewards, even ones that aren't drug-based, and in initiating movements. So if you have Parkinson's disease, that's because some of the dopamine neurons in your brain have stopped working. So you have to take supplementary dopamine or dopamine agonist, that is a substance that imitates or produces more dopamine, in order to alleviate those symptoms. And the symptoms are difficulty initiating movements. But there's also evidence um, that the reward-based decision-making of Parkinson's patients is disturbed. It's not just that they have trouble controlling their movements, but also that they have trouble perceiving and interpreting rewarding stimuli. So again, evidence that the basal ganglia are dependent on dopamine, but that they also process both rewards and actions. And again, this link makes sense because it's actions that are often involved in getting us more rewards. And so we increase the likelihood of actions that get us rewards and decrease the likelihood of actions that don't get us reward or in fact get us punishment. Okay, so again, job well done on those discussion questions, and be sure to participate every week. So this coming week, you'll again participate individually. After that, what I'm going to do is put everyone into discussion groups. And what you'll do there is when I post a question, as part of your group, we'll decide which question they want to respond to, and then you'll craft a response as a team. And I'll go over a little more about that next time, but just be ready for that. So this week, respond individually as before. Next time, I will put you into groups. Okay, moving on. So looking at drugs in society, first we're going to look at the individual. And again, we've already looked at the brain and neurons. So looking at the individual as a whole is what we'll be doing this time. So we'll be talking more about the negative consequences of drug use in this session. And that's more of what this week is about, is some of the negative consequences. We'll get into the positive consequences later on. But when we're talking about drug toxicity, there are a couple of ways to describe toxicity. Of course, toxicity itself just means the degree to which a drug is poisonous or dangerous to one's health or lethal even. So a distinction that's made is between physiological toxicity and behavioral toxicity. And as your book points out, this is to a certain degree sort of an artificial distinction. Obviously, our behavior depends on our brain, and our brain is a physiological organ. It has physiological processes. Altering the balance of ions in the brain can change how it functions. Altering the availability of certain neurotransmitters, certain nutrients. All these things can affect how the brain works, and that will ultimately affect behavior. But the distinction between physiological and behavioral toxicity, while it is a bit nebulous in certain areas, we can talk about physiological toxicity in terms of what it does to the body. So basic physiological processing that's perturbed as a result of drug use versus behavioral toxicity, which are things like behaviors that normally aren't dangerous but either become impaired through the use of a drug or become exaggerated. And so these are behaviors, these are products of our nervous system, products of our actions that make the drug dangerous. So physiological toxicity would be something that affects breathing or affects heart rate or affects liver function, any of the organ systems in the body. Whereas behavioral toxicity would be something like an impairment in memory or an impairment in coordination, an impairment in judgment. So these are all cognitive processes, and though, as I said, they depend on physiological underpinnings, they're at sort of a larger scale of description. They describe our interaction with the world around us. Physiological toxicity could happen to an individual in a locked room where they couldn't really do anything, whereas behavioral toxicity really involves the interaction with the environment. And again, this is sort of an artificial distinction because it's not clear where one necessarily ends and the other one begins. Behavior depends on physiological processes. But it's sort of a convenient distinction to make, so we'll stick with it to a certain degree. The other distinction that's important is acute versus chronic toxicity. And you may already be familiar with these terms, probably are. So acute toxicity is something that happens suddenly. It's quick It's quick to begin, it's quick to end, whereas chronic toxicity is something that takes much longer. And usually it takes repeated use of a drug, and often chronic toxicity uh, is the effects of chronic toxicity are present whether the drug has recently been taken or not. So an acute effect of drug toxicity would be, for example, the decrease in heart rate that occurs when someone takes an opioid, a pain-killing agent of a particular type, or an increase in heart rate as one gets with cocaine or amphetamine. Uh, as soon as those drugs wear off, the effect wears off. Whereas chronic is long-term. So a chronic effect of smoking, for example, is high blood pressure. A chronic effect of alcohol consumption is cirrhosis of the liver, scarring of the liver. Chronic effect of opioid use are symptoms like constipation. You may have seen recently commercials for that seek to alleviate opioid-induced constipation. So that's a chronic effect of opioid use, even when it's used as prescribed. So again, this is a short-term versus long-term distinction. And you can mix and match these two concepts. So you can have acute physiological, acute behavioral, chronic physiological, and chronic behavioral. And this table from your book lists examples of each kind. So for example, a chronic behavioral effect would be a change in personality or loss of long-term memory. An acute physiological effect would be change in heart rate when the drug is taken. But you can see that there are instances of each kind of combination of effects. Okay, so those are sort of the individual effects of drugs, and as I mentioned, particularly the negative ones. Um, the question is, when we start talking about drugs in society, how do we get our information? So how do we know what drugs are commonly used? And this is important from a social perspective to understand how common drug use is, um, especially when it comes to drugs that are deemed dangerous. And we'll talk about why drugs are dangerous or not as the course goes on. And that's a topic we'll revisit again and again. Uh, but organizations like the Drug Abuse Warning Network, otherwise known as DAWN, and this network, this organization, logs what drugs have been taken by an individual if they come to the emergency room. Now, it's not to say that the drug was the cause of the emergency room visit, although often it is. That's not the distinction that's being made. So it's just whether the drug is present in the person's system. And unfortunately, alcohol gets sort of a free pass in this situation, as does nicotine, because these are legal drugs, at least for adults. If alcohol is taken in combination with these other drugs, then it is mentioned. But otherwise, it gets sort of a bye. But it allows us to look at the number of emergency room visits uh, as a function of what drugs are in the person's system. Again, not attributing the cause, but it helps us estimate how common a particular kind of drug use is. But again, it's filtered by whether the person's in the emergency room or not. So if there's a drug that's really frequently used, but doesn't result or isn't associated with emergency room visits, then that will not be on DAWN's radar, so to speak. So we can see from this table that alcohol is commonly involved in emergency room visits, not to say it causes them, but in combination with other drugs, it's very common. It's the most common drug, followed by things like cocaine, opioids, marijuana. And again, this is looking at a very particular phenomenon, that is emergency room visits. So these are not necessarily estimates of drug use in and of themselves. They're looking at the combination of drug use and emergency room visit. So this is collected by healthcare specialists, professionals, which makes sense given that it's emergency room visits. Organizations like the Centers for Disease Control and Prevention, often referred to as the CDC, also collect data on drug use. And here they're looking at causes of death. So now we do have some assessment of cause. So the drug caused this event, not just was involved in. but actually cause the person's death. And this is particularly useful for drug overdoses. And it may surprise you to know, maybe not, but it surprised me when I learned it, that at least when I was growing up, you hear things about things like cocaine and heroin, the illicit drugs. And you're led to believe that these cause a lot of negative health effects up to and including death. It turns out that the CDC has published research showing that actually prescription pharmaceuticals, and especially prescription opioids, are responsible for a large proportion of drug overdoses. Again, anti-drug campaigns and the media, not that these effects are bad, discourage illicit drug use by describing how dangerous these drugs are, especially things like heroin and cocaine, which were popular when I was in high school and were also perceived as the most dangerous. But it turns out they don't cause all that many deaths in and of themselves. Despite the fact heroin is an opioid, but this study is looking at prescription opioids. Heroin is never really prescribed, at least in the U.S. That is to say, it's seldom prescribed. There are cases. One thing these things don't really control for, though, is frequency of use. So again, we talked about in the first couple of weeks of class, estimating how often drugs are used by people in the U.S. And this is often, this information is often obtained through things like surveys. Again, looking at emergency room visits, looking at deaths, these are very specific events, very specific phenomena to look at. And it doesn't necessarily tell you how common use of that drug is in society at large. If it's relatively safe, then it may be frequently used, but not cause any deaths and not be involved in many emergency room visits. So we have to be aware of the importance of frequency of use when we're talking about drug statistics. So this also tells us something about if we do independently assess frequency of use, now we can start to talk about how dangerous a particular drug might be. So cocaine involved in a number of deaths, a number of emergency room visits, but its frequency of use is actually not all that high, which means that in order to generate that many emergency room visits, it actually must be fairly toxic because in order to get that many emergency room visits with not that many users, the chances of an emergency room visit, the chances of toxicity, must be pretty high. Whereas almost everyone uses alcohol at some point, so it's not that surprising that we have a lot of alcohol use coming into the emergency room. So we always have to adjust our the impact of a particular drug in terms of death or emergency room visits by how commonly used that drug is. Something similar could be said for heroin, which is not to say that we should look only at frequency of use normalized data, or that we shouldn't. That's an open question. So if a drug causes a lot of deaths, but is also commonly used, should that be the target of an anti-drug campaign? Or should it be the drug that isn't frequently used, but causes a disproportionate number of deaths? So one is more common and may cause more deaths overall, and the other is less common, but relative to its use is actually fairly dangerous. Which one do we address? There's no obvious answer to that question. I leave that to you, and obviously elements of the media, the government, our society have come down on one side or the other of that idea. But there's no go-to answer. Do we care more about what causes more deaths overall, or which is more dangerous per use? Open question. A quick word about intravenous or IV drug use. One of the most important side effects of drug use is a behavioral side effect, and that is the threat of bloodborne diseases. And this was very important when I was growing up, for example. So spreading things like hepatitis B, and in my childhood, the spread of HIV. And actually, one of the things that's been interesting to see as time has gone on is that people don't talk about AIDS as much as they used to, as they did 20 years ago. Now it's mainly about HIV. And the spread of HIV, when I was growing up, a lot of it was through the sharing of needles by IV drug users. Now, thanks to media campaigns, that has gone way down. But now HIV is primarily spread sexually. But at the time, it was IV drug use was a big cause of the spread of HIV. Also, as I said, it's the term HIV is used more commonly than AIDS. AIDS, of course, is the advanced stage of HIV infection. It's so that people don't spread AIDS, although that was the way it was described 20 years ago. People spread the HIV virus, and then AIDS is a consequence of having an HIV infection. And now part of that, part of the reason for the change in terminology is that AIDS, the concept became stigmatized. And so in order to avoid that, in order to have a more open discussion, in order to not not force people with HIV to go into hiding effectively, the need was there to destigmatize HIV and AIDS. So that term has gradually transitioned. Also, with more effective treatment, it's now very likely, in fact, that someone will have HIV without developing AIDS, whereas 20 years ago, having HIV was almost inevitably going to lead to the person having AIDS. Anyway, so HIV, hepatitis B, these can all be transmitted through IV drug use. And so one of the big consequences of drug use, of intravenous drug use, at least historically, was the spread of bloodborne diseases. So that's a social effect. So now we're talking about more than just the individual, now we're talking about society. And one of the ways that was devised to address this issue was the concept of needle exchange programs. And this is a method by which an IV drug user could bring in a needle they had used and exchange it for a clean one they could now use. And so but they could get free needles, free clean needles, and wouldn't have to keep on trading, keep on swapping used needles back and forth. Again, the point being to decrease the spread of bloodborne diseases by providing clean needles. Now, there's always been some opposition to this. The idea being that by giving out free needles, that these agencies would either be encouraging or at least not discouraging intravenous drug use. That we would end up with more IV drug users because we were giving out free needles. The evidence doesn't really bear that out, and this has been going on for decades now. And so, and certainly the spread of bloodborne diseases by IV drug users seems to have declined significantly. So this is one of those examples that I think fairly unambiguously has been a positive. So it doesn't seem to increase IV drug use, but it does significantly decrease the spread of bloodborne disease. So it's sort of a win. Okay, so that's going to wrap it up for this session. Next time, we're going to continue our discussion of drugs in society. So this time we talked more about the individual and started getting into society. And next time we'll talk more about society at large. And we'll talk about things like models of drug dependence. So how has society and psychological and medical professionals in particular, how have they approached the problem of drug dependence? So how do you describe it? How do you define it? When is someone dependent on a drug? What causes drug use and drug dependence? So if we're looking to diminish use of a particular drug or misuse of a particular drug, we need to know what the causes are first. And then finally, given the phenomenon of drug use, how is it related to impact on society? And in this particular case, we'll talk about crime. How is drug use related to crime? Does it cause increased crime? If so, why and how? So those are all topics we'll talk about next time. So I will see you then.